So, what is BLE Audio all about? Well, to answer that question, we'll explain why you couldn't do BLE audio before the version 5.2 revision. Firstly, the maximum data rate of 2 megabits per second wasn't sufficient to transmit high quality audio transmission. It just wasn't enough. Secondly, there was no streaming technology in BLE. I'll explain what I mean by that in a minute. So you would have to do any custom implementation of streaming, and also as a sort of further point, the early generations of devices were rather limited in terms of processing power and RAM and flash and so on, which for resource-hungry codecs was also going to be a problem. So how have these been solved? Well, firstly, BLE 5.2 implements a streaming technology which has been named Isochronous channels. I'm not sure I would have gone with that name, but I guess it does sort of make sense. So what does that mean? A classic data transmission, as was in the earlier generations of BLE, it's about reliable data transmission. You want all the data to arrive in the right order, so you can reconstruct exactly what was sent. So in this example, we have some packets of data going, and let's say the third one, for whatever reason, you miss a transmission because there's some noise or whatever happens. This can happen in wireless. So you retry it a bit later, and if it succeeds, you carry on. So you end up with all the data packets received and the full data parcel arriving the other end. Now streaming, it prioritizes the timing. So in the second case, you have your first 3 data packets, but you lose the third one. Well, you just reject it, throw it away, and move on to the next one. So you keep the timing of the original data that was sent, so you receive it the other end. Now, clearly, as relates to audio, this is what you want, because if you have a small dropout, you might lose a little bit of quality in the sound, a little glitch maybe, but you don't tend to hear those things as long as it's not a major data loss. Whereas you would tend to notice if it stops and starts, it interrupts your enjoyment of listening to the music or whatever it is. So that's what the streaming is, and that's what's been implemented in BLE 5.2. And actually, the streaming services available are much more complete than they ever were for the classic Bluetooth versions. So you have multi-channel, so you can have multiple independent channels, so stereo or even more Dolby 5.1 type transmissions, and you can also have one-to-many, so you can have a kind of broadcast capability. So one source can go to 2 end devices, so 2 people could listen to the same music on headphones. The other big move forward is a new codec, the LC3 codec. Strictly speaking, this isn't actually part of Bluetooth. I mean, you could use this codec for any audio compression task. It doesn't have to be done in the context of Bluetooth. Now, this has a higher compression rate, so the same starting audio file will end up with a lower overall data volume to be transmitted. But the clever thing about the LC3 is that it does this without reducing the perceived audio quality. Because of course, if you're listening to music, what counts for you as a listener is not what percentage of the original data is lost theoretically, but how it sounds. And this is something the LC3 codec tackles. So the graph on the right shows the drop in perceived audio quality with listener tests at different data rates, with the LC3 in blue and the older SBC codec in grey. And on this scale, 5 is indistinguishable. You can't tell the difference between the original and the coded and decoded audio. And what you see is the LC3 codec has quite even when you go down to relatively low data rates, there is very little loss in perceived audio quality. And then on the device side, devices for Bluetooth Low Energy have become more and more sophisticated. So Insight SIP has a new module in our standard 8x8 by 1mm package, so it's very small. And this is based on the Nordic NRF 5340, so the top-end Bluetooth device. And this has lots of processing power. It has dual-core M33 processors. It has lots of memory and flash, so you can run the codecs because they're quite resource hungry. No problem running stereo or even more codecs on board. So this is a very powerful device that can do the bulk of the functions for the Bluetooth Low Energy audio. So here is the Bluetooth Low Energy demo board. So you can see it's a nice little small board. On the top of the board, just underneath my thumb, is our ISP 2053 module that is doing the bulk of the work of the board, and then we have some various other components which I'll explain what they are. So here I'll explain exactly what is on the BLE Audio Demo board by Insight SIP. So the heart of the system is the 2053 module. This contains the Bluetooth radio, it contains the antenna and all the RF parts, and then inside you also have the dual-core processors which handle running Bluetooth, the underlying streaming technology, and then the codecs also run within this module. So the bulk of the BLE audio function is all carried out within this module. You don't need many other things around it. The other significant component for the audio part is the audio DSP. It's a Cirrus Logic device. This we're using really just to do the analog to digital, digital to analog conversion. There are many other features on that that are quite interesting for a sophisticated audio application, but that's what we're using it for. The 2053 does have analog to digital converters on board, but they're not really of the right quality for audio. They're more for sensing, measurement type applications where you don't need the same level of precision. Otherwise, there's a microphone on here, so you can send data, audio in both directions. Out, you can receive, say, music in and send voice audio back. There's a reset button. These are really a bunch of in the middle, there's some power regulator things to power the different chips, and some buttons to control. But really, the two devices form essentially all you need really to do the audio function. So now I'm going to demonstrate the BLE Audio Demo. So we have our two BLE audio boards here. So just to start things off, at the moment I've just got the phone connected directly to the speaker just to show, so it's a simple analog audio out. Not so many phones have this these days, but this is a bit of an old phone that has one. So if we start playing the music, and we hear the audio. So now we will disconnect the phone directly from the speaker. We will put it in the audio in jack of one Bluetooth Low Energy Audio Demo board, and then we connect the speaker to the other. So there's now no physical connection between the two, but we will get the wireless connection. And so again, we have to press play, and again the audio starts up as before. And we can also control here the start and stop the audio. By these little buttons, and we can also change the volume. A bit fiddly, these buttons. So clearly, normally going forward, what we would want to see is the Bluetooth Low Energy direct audio directly on the smartphone, and so you don't be faffing around with cables, and then whatever device you want to receive the audio would just have effectively the circuitry on this board here. So stop the music now. So that illustrates the Bluetooth Low Energy audio. It works very well. It gives you a good sound, and it's ready to be implemented into devices.